Is underground infrastructure vulnerable to earthquakes? Imagine a city where the streets are quiet, but beneath your feet, a network of tunnels, pipes, and cables runs silently through the ground. Have you ever wondered how these hidden systems hold up when the earth starts to shake? Well, it turns out that underground infrastructure is generally better at withstanding earthquakes than buildings and bridges above ground. But it is not completely safe from the seismic forces that ripple through the earth. The level of vulnerability depends on several factors like the type of soil, how deep the infrastructure is buried, the quality of construction, and how close it is to the earthquake's epicenter. Earthquakes send seismic waves through the ground, causing it to shake and move. Structures above ground experience inertial forces that can cause them to sway or collapse. But underground systems, such as tunnels and utility lines, tend to move with the soil and rock around them. This means they often experience less stress and relative movement during shaking. For example, tunnels bored into hard rock or stable soil are usually more resilient because seismic waves are less amplified at greater depths. However, not all underground infrastructure is equally safe. Shallow tunnels in soft or loose soils are more prone to damage because the ground can deform or shift more during an earthquake. Soil liquefaction is a big concern here. It happens when saturated soil temporarily loses its strength and behaves like a liquid during strong shaking. This can cause the ground to sink or crack, damaging pipes, cables, and foundations. Different parts of the ground can also move unevenly, creating differential soil movement. This uneven shifting can strain or even break underground utility lines and pipes. Older infrastructure or systems that haven't been maintained well are more vulnerable too. They may lack modern seismic design features or have deteriorated materials that can't handle the stress. Damage to underground systems during earthquakes can cut off water, electricity, gas, and communication services. This can lead to secondary hazards like fires, explosions, or traffic jams if roads and tunnels are affected. Knowing these risks helps in planning better emergency responses. For example, having backup water and power sources ready can make a big difference if underground services are disrupted. Upgrading infrastructure with features like flexible joints in pipelines or reinforced tunnel linings can boost resilience. During an emergency, understanding that some underground transit systems might stay operational or be less damaged than surface structures can guide evacuation plans and shelter choices. In the end, underground infrastructure often holds up better than surface structures during earthquakes, but it's not invincible. Soil conditions, ground failure, and aging materials all play a role in how well it survives. Being aware of these risks and supporting infrastructure improvements are key parts of being prepared for natural disasters.